All right, for this standard, I did the second problem, which is problem 248 in the book, which reads, it's the Archimedean principle. This principle states that the buoyancy force equals the weight of the water displaced by the body, partly or totally submerged. The cylindrical buoy of diameter 60 centimeters in figure 43 is floating in water with its axis vertical. When depressed downward in the water and released, it vibrates with period 2 seconds. What is its weight? So we have diameter of 60 centimeters, period is 2 seconds. We're looking for the weight. So force equals mass times acceleration, which is m times the second derivative of y, which is how far it's pushed, like where its placement is. So that equals the force of gravity times pi r squared times y, which is right here. And then we have m times the second derivative of y plus ky equals 0. Y equals a cosine omega t plus b sine omega t. Omega equals the square root of k over m. The period is 2 pi over omega, which means that omega is 2 pi over t. So omega equals omega, so square root of k over m equals 2 pi over t, which is right here. If you square root this side, or square both sides, you have 2 pi squared over t squared equals k over m. So then you have m equals kt squared over 2 pi squared. The period is 2, so you can plug that in for the t, and m equals k over pi squared. So then we just need to solve this equation for k up here. So we flip it around and have k equals m double y double prime over y, which equals 9.81 times pi r squared times y over y, so the y's cancel, and the k equals 2.77, so plug that in what we found m to be, so 2.77 over pi squared, so the weight is 0.281 kilograms.